Hello, some of you requested to see the little guy. Here's my little guy. This is Elijah. Oh, big one. He's supposed to be sleeping right now. He's in his jammies. He can these at night, these videos. He's not sleeping, clearly. So, here I am showing you Elijah as he requested. He is a big kid, very big kid. If he keeps with this trend of being so big, he's going to be like 6'4", which I have nobody in my family who's even close to 6'4". So, should be interesting to see. There he is. I'm going to try to put him to sleep, but I thought I'd show you him first. All right.
All right, Elijah's asleep now. I also wanted to say real quick about the grades. Thank you for being honest about what you think about the grades, and your comments were priceless, and I could tell that you were really being honest with me, and because you trusted me enough. So thank you for that. I'm hoping that you can trust me a little bit more because I don't have any answers. Like I said, I don't know what I'm going to do exactly. I know that I'm going to do something, that's for sure. But tomorrow I have a meeting at 10, and they're hopefully going to give us more information on things. So I don't want to make any decisions out loud yet, but I have a lot of things in my head, and I guess you'll just have to trust me. Okay, so thank you. I'm going to go over next the top questions. You can see on the screen here, this is like where our ranges of all of our scores are lying, and these are the top questions. The ones I'm going to go over here are 2, and then 7, 8, 9, 10, 11, 12. So if you need any help on those, that's what we're going to talk about next. I'm going to start with number 2. If you don't need help, you really don't have to listen to this video. It's okay. You can skim through. Okay, number 2. So number 2 is about the melting point of MgO. Now, MgO is higher than NaF. If we think about the two things that we have, I'm going to take them one by one. Mg2 plus is more positively charged than Na plus. That is a true statement, and yes, that makes the melting point higher. There are two things that affect the melting point, or the amount of attraction, IMF kind of forces that they have between MgO or NaF. So it could be charges or it could be size. So the greater the charge, the higher the attraction. So that's why number 1 is the correct answer, because Mg has a 2 plus, Na has a 1 plus, they'll be more attracted, thus a high melting point. Number 2 is also a correct answer. O2 minus is more negatively charged than F minus, so therefore MgO will have a higher attraction, stronger IMF. According to Coulomb's law, this is all about, thus it'll be harder to melt. Number 3 is about size, and it is true about size. So the size would be, the smaller it is, that would be according to Coulomb's law, the distance which is on the bottom will be less, so therefore the Coulombic attraction will be greater attraction, higher IMF, thus a higher melting point. However, the statement that O2 minus is smaller than F minus is not true. O2 minus is a bigger ion than F minus. Go to the periodic table. O2 minus is, here's O, 1, 2, he's neon. F1 minus is 1 more, is neon. So they both have the same electron configuration as neon, but O has gained 2 electrons. That right there makes it a bigger ion. The real reason why O2 minus is a bigger ion is because F has a greater ZEF, greater effective nuclear charge, because it has 9 protons to hold those 10 electrons in, while oxygen has only 8 protons to hold the 10 electrons in. So therefore, although size is an issue here, this statement is incorrect. F is actually the smaller ion than O. So that's why 3 isn't a good answer. Okay, now we got to go to number 7. Okay, so for number 7, everybody that got it wrong wanted to say D, but it's really A. And if we think about it, what this is really showing is resonance here. So, I mean, I can understand why you'd want to pick D. It contains 3 single bonds and it has 2 double bonds. But really, if we think back to resonance structures, it's not that the structure is actually like this one on the left, and it's not that the structure is actually like this one on the right. The actual structure of benzene, which is what this molecule is a hybrid of the two. It's like these two are meshing together, so it's continually having 1 bond or 2 bonds at the same time. So we have to think about the averaging. So the averaging of all this would be, since this is happening at the same time as this one, if we average them together, it's like every bond is like a bond and a half length. So a 1 bond length would have a longer distance than a double bond length, which would have a shorter distance. But if we actually found the bond length of all these CC bonds, it'd be in between those two. It wouldn't be as short as a double. It wouldn't be as long as a single. It'd be like in between. It'd be like a single and a half or 1.5 bonds. That's why A is the right answer and not D. Okay. Number 8. Yeah, this one's a tricky one, right? We definitely got to relook at Lewis dot structures and We have to look at hybrid orbitals, we have to look at Lorentz structures, and formal charges. That's something we got to look at. So let's look at here. I'm going to go down to this one here. This one is not a good answer because if you look at the O, it's completely naked. You only have 6 electrons around that O and you need 8. So that one is not a good one because the O is all messed up. If you look at C down here, I've got an N. N has 5 valence electrons. Another N has 5 valence electrons. And then an O comes with 6 valence electrons. If I add that up, I get 16 total electrons I have to count for. Inside this structure, there's actually 18 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wait a minute here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There, now I counted right. So that structure has 18 electrons in there, and you can really only have a total of 16. That's why that structure just simply doesn't exist. That brings us down to A and B. So that's when we have to look at formal charges, which is kind of what they're suggesting. But they're kind of suggesting, like, look at formal charges at all times, and that's why we get all messy in that C and D. So let's rethink back to formal charges. Formal charges is the idea of, does each atom have the number of electrons that it wants to have? Like oxygen. Oxygen comes with 6 electrons, so really he wants to have 6 electrons. So here we have 1, 2, 3, 4, 5, 6. He came with 6, he has 6, he has a formal charge of 0. If I look at nitrogen, nitrogen comes with 5 electrons. So really he wants to just have 5 electrons. But he has 1, 2, 3, 4. He only has 4 electrons. Now electrons are negatively charged, so that means his formal charge is going to be in the positive range because he doesn't have as many electrons as he wants. He wants 5, he only has 4. He has a formal charge of plus 1. If I look at this nitrogen over here, he has 1, 2, 3, 4, 5, 6 electrons. He has 1 more electron than what he really would want because he comes with 5. He has 5 electrons. So he's a -1 for a formal charge. Those are the formal charges for that one. If I look at my next one down here, I think I got to redraw it over here, otherwise it's getting tight. Okay. So again, nitrogen comes with 5. So 1, 2, 3, 4, 5. 5 electrons are around or like housed by that nitrogen. They belong to him, so he has a formal charge of 0 here. This nitrogen here has 1, 2, 3, 4. So again, he has less electrons than he wants. He's +1. And then my last one over here is my oxygen. He has 1, 2, 3, 4, 5, 6, 7. Come on in. He has 7, so he has 1 extra electron than he wants. Oxygen normally comes with 6. He has 7 here, so he's a -1. So between them all, first thing I got to look at is my formal charges. They have to all add up to 0 because this is a neutral molecule. It's not like an ion. 0 plus 1 minus 1, that has a 0 formal charge. This one over here, -1 plus 1, 0, 0 formal charge. And then the last thing I should look at is, okay, who has the minus and would want the minus? Over here, the nitrogen has the -1, and over here, the oxygen has the -1. Between the two, oxygen is more electronegative, which means this is the more stable structure. The one who's more electronegative has a formal charge that is negative, therefore, it's the better structure. Okay. That would be that one. I'm looking at number 9. Okay, so if you got number 9 wrong, you said C, or most of you said C. I don't think everyone did. So this is when we're looking at bond angles, and I can tell we have to look at the Vesper chart. Great thing for people who like hate the Vesper chart is that this is going to be an open note quiz or test for the AP test. So you don't have to memorize the Vesper chart. We just got to have it in front of you. We're going to deal with this as we go on. The AP people are coming out on April 2nd at 7 p.m. Eastern time, so that's when I'll find out more about that. Okay, so looking at the answer is D here. We're looking for something that's closest to 120 degrees, which is like 3 things around there. If you take a look at C, which is the most popular answer to say, and it was wrong, is see how N has 1, 2, 3, 4 things around it? These lone pairs around here do count as a thing. They're still repelling things around them. So this one here is more of a tetrahedral shape, technically a trigonal pyramidal. It has a 107.3 degree angle. This is the best one because that carbon right there has a 1, 2, 3 things around him. that's got a bond angle of 120. Not exactly, but as I said, closest to 120. So that's why I got that one. All right, I'm going for number 10. Okay, hybridization. Okay, so if you got this one wrong, you most likely said C. Now, D and E, see how it has the D block in there? They're never going to do D block answers. This one I'm surprised is even in there because AP specifically said we won't go into the D block. So really, you had to narrow down A, B, C. So SV3 is what most people said. And here's why I think you said that. It's because you're thinking S and 3 Ps, that makes 4 things. And you were looking around the carbon, you're like, oh, there's 4 bonds around carbon. That's not the way to look at it. You want to look at, okay, here's the C. It has 1 thing, 2 things. It has 2 things around it. It doesn't matter how many bonds, just how many things are around it. Since the C has 2 things around it, it's called SP. That's on my to-do list. You can see what to review. That's on my to-do list for things we got to go over together when we go over Unit 1. But it's nice to talk about it here, so you get it here and again. 11. Okay, so I think what I got to talk about here is A. That's what I have in my notes. Okay, so which of the following things is supported by the diagram? Okay, if we look at the right answer, the strongest carbon-to-carbon bond is in molecule 3. And that's true because this is a triple bond right here. A triple bond is much stronger than any double or single bond. But if you got it wrong, you said A. All the atoms in the molecule are in one plane. This is not a correct answer. I mean, on the paper, it looks like it's all in one plane because we draw it that way, but we have to think in 3D. So like if you look at the carbon, it has 1, 2, 3, 4 things around it. That's a tetrahedral shape. That means that when you have it, it's not up, down, side, side. It kind of warps itself to make it 3D. If you think it's all in one plane, that negates the idea that the world works in 3D. So that's, I feel like an okay answer for that. It's also easy. I guess I'm going to do that. 12 is my last one. We did okay on the free response. I'll talk about it in a second. Okay, 12. Okay, if you got it wrong, you said A or D. If you have C and Se, they have an electronegativity value of 2.55. So if there's a bond between those two, that means each of them loves electrons equally. They each love electrons at a 2.55 level on a 0 to 4 scale. So that would be a nonpolar covalent bond that they have. If you got it wrong, you said it was A, it was one person. Unstable, the word unstable, I'm gonna even like go out there and say it's never gonna be a good answer because saying something is unstable isn't explaining why it's unstable. Why would you say it? It's a very vague term, so I would never go for the unstable word answer. I wouldn't use it in my answer in a free response, and I wouldn't circle an answer that has that. It's just too vague. Because when I see the word unstable, you're like, well, why? What does that mean? Or you might have said D, molecular compound with partial negative charge on the carbon atom. You can't have a partial negative charge on the carbon atom because it's not like carbon wants the electrons more than the other guy. You can only have a partial negative if one atom loves electrons more than the other, like water. Oxygen is partial negative because oxygen loves electrons more than the hydrogen does. So therefore, it'll have a partial negative. Okay. Looking at our free response questions down here, I didn't ask you to do like these ones because that's impossible on Google Forms, but when you wrote your answers to part B, I think some of you were like, I don't know, but it was really as simple as it had to be part of the same family as the chlorine. So if you talked about the same group or the family, and that's the most common answers that I saw, you did good there. Sometimes it feels like this answer is so short and I don't have a very like sciencey answer to it, but that's fine. For this one, that's totally fine. That's mine. I don't have anything to do at the end of this video here because I want to save it for my tomorrow video, the one I have in my head here. So that about sums her up. I know that some of you might be struggling with these questions. That's okay. We've got like a 2 months, a month and a half at least to figure this all out. So don't stress it if things aren't coming back to you like you want it to. Figure it out. We'll get there. It's like that commercial. I love that commercial where they got the doctor and you're like, are you nervous? Yeah. Yeah, we'll figure it out. I'll see you in there. I love the commercial. It cracks me up every time. But really, we'll figure it out. It'll be fine. Cool. That's all I got. Hey, get some sleep.